This is question 4, Higher Maths 2012, Paper 1. Have a straight line and an angle that that line makes with the x-axis, and we're asked to work out the gradient of this line. Now, basic result, x-axis, straight line, angle theta, the gradient of this line will be equal to the tan of theta. It makes sense when you think of a right angle triangle where the tangent of this angle is opposite over adjacent. Distance up divided by distance along is the gradient of that line. So it does make sense that the gradient is that tangent. And certainly a situation also that looks like this, where the angle is greater than 90 degrees. This is a second quadrant angle, if you like. The tangent of that angle is going to produce a negative result for the gradient, and this line is certainly going downhill. Negative gradient downhill, positive gradient uphill, travelling from left to right. So the gradient now will be the tan of 150 degrees. And that's what we need to work out. And unfortunately no calculators, we can't just put that into our calculator and see what happens. And certainly these are all exact values. Calculator will give us a decimal approximation of these, but paper 1, no calculator, we need to do a bit of theory here. So tan 150, let's go to the quadrant diagram, first, second, third, fourth quadrant, and you may remember that the unit circle, that's just a circle with radius 1, this angle of 150 degrees, the coordinates of this point, whatever they are, x coordinate, y coordinate, and the tangent of this angle would be the y coordinate divided by the x coordinate. You can see that in the corresponding position, the symmetric position here, where we've just turned around 30 degrees. It's 150, there's 30 degrees to go to the 180, but there's a corresponding position in the first quadrant with the y and the x, and again there's your SOHCAHTOA, the tan of 30 opposite the y coordinate divided by x coordinate, the adjacent, y over x. And the tan of 150 is exactly the same for this point, y divided by x. Now the y coordinates are identical, the x coordinates are not. Whatever this x coordinate is, this will be the negative. So we've got the result that the tangent of 150, because the angle produces a line in this quadrant with an x coordinate negative compared to positive x coordinate, y divided by x will be negative compared to this one. That's a long way around to say basically that when we're working out the tangent of 150 degrees, we'd better just work out the tan of 30 and make it negative. You possibly know all sine, tan, cos. An angle in the second quadrant where this line rotates, its starting position is always down on the x-axis here, but it rotates 150 degrees into the second quadrant. Only the sine is positive. The cosine and the tangent are negative. That's what these letters mean. Only the sine is positive in the second quadrant. 150 degrees is a second quadrant angle. The tan must be negative. And how far do we go to 180, 30 degrees? So the tan of 150 will be the same as tan 30 numerically. The sign will be different. We have to put a negative in there. So we've reached a slightly different problem. We've reached the problem where we need to now work out what the tan of 30 is. So let's think about that. 30 degrees can be obtained if we take an equilateral triangle. All angles, of course, are 60 degrees in there, and chop one of them in half. So instead of 60 up there, we've got a 30 degree. This will still be our 60 degree. And lengths in this, it doesn't matter what we make the lengths. If we made them side 1, then this would be a fraction and a half. So let's make them side 2. All sides are 2. That whole side is 2. So let's just half that side, and we'll get a 1 there. In this right angle triangle, Pythagoras would give us the exact length of this third side. Now, it's not the hypotenuse, it's one of the smaller sides, so it's the square root of 2 squared minus 1 squared. Square root of 2 squared minus 1 squared. That's the square root of 4 minus 1, square root of 3. So that side, the remaining side in this triangle, is root 3. So to get the exact value of tan 30, remember SOHCAHTOA, TOA, tan 30 is opposite over adjacent. This is the hypotenuse. So tan 30 opposite over adjacent. That's 1 upon root 3. So tan 30 is 1 upon root 3. And we have to make it negative because we were in an angle in the second quadrant. So the gradient of this line is exactly negative 1 upon root 3. And this choice here gives us that. So it's choice B.